All right. So we have some grass in our game. It's not much of a game, I guess, but we have some grass in an application in 2D. So I think what will be cool is to add some movement to this grass. We could, for example, animate it in the wind or something. So we want some way of moving these vertices around, and right now the actual positions of them, we upload this vertex data once at startup, and I guess one way to animate this would be to just upload it every frame and generate some different positions of these blades depending on some wind function, I guess. But an alternative is to do this in the vertex shader also, so kind of like skinning, but not really. But we'll basically modify the position of the vertex somehow procedurally, which I think that should be pretty simple. Well, but one thing I guess is that we would only want these these tips of the grass blades to actually wiggle around. So we need some factor, I think, per vertex, or some weight that tells us how much that vertex is going to move in the wind, because they're still gonna stay static here, right down here. These aren't gonna move regardless of how much wind we have. So I think we can actually put that in the vertex color attribute, because the alpha channel, we don't use the alpha channel right now, and I don't think we actually need or actually want what's it called? We don't want semi-transparency, at least not with these things. Like that would be a completely separate pipeline if we ever do want it in the future. So, but if we put it, we can put it in the vertex color, because we want to use the red, green, and blue channels right now for actually coloring the vertices, and this is just completely unused in the shader right now. We can see that here. We have the packed vertex color, which is a full 32-bit uint, and we only use the 12 lowest bits. Oh no, the 24. Yeah, 24 bits, yeah. So we have 8 bits that we can use for the actual animation weight. So let's extract that. Let's say that is the vertex. Let's say an animation weight. All right, and that's in the packed vertex color. In the 8 highest bits, or the most significant bits. So just shift it like that, and that should be enough. We don't have to mask it out. Yeah. And depending on this weight, we will modify the vertex position, and maybe we want to, we can Yeah, we can just make that non-const, and we'll just basically modify this. And I think it's gonna be pretty simple now because it's on a flat plane, all of them. We might have to complicate things a bit later, but let's do some very simple wind procedural wind model. Oh, do we actually? We're gonna have to use some kind of elapsed time to do this animation. And do we pass that in right now? No. We can put those in the frame uniforms. So for each frame, we know, I guess, some. I think this will be the elapsed time since the program started. Maybe in terms of seconds, probably. And let's call it elapsed time. Sounds good. So we will use the elapsed time. Let's just put that into a sinus function. And we probably, yeah, we have to scale it by this weight. So that if it's static, it's gonna be 0. So this is just gonna evaluate down to 0. And I want some factor, because if I take the sine, that's gonna be a lot. That's gonna move like 1 meter in both directions. So I think this is probably gonna be much still, but we'll see if it works first of all. So we only, let's see, vertex 0 of this triangle is the top one, so we actually want movement in that one, and these are the 2 bottom ones, so we set the weight to 0. Maybe we can call it animation scale or something, but oh well. And all of these should be 0 as well. And maybe that's a nice way of doing it actually. Yeah, because that's like static geometry, that's gonna be 0. And now we actually have to pass this elapsed time into the uniform buffer, and let's see where we can get that from. Where is this? This is inside of scene draw. Maybe we can put that in the render context. Yeah, we at least we have like the delta time. Okay, we don't actually track the elapsed time, it looks like. So what is this actually? Is it the delta time in seconds? I guess we can check that. Print this. Delta time. That's probably milliseconds. Let me just start, I guess, by, we need to keep track of the elapsed time. Well, maybe we can add that functionality into this delta timer actually, because Well, okay, is this reset only called... Yeah, that's called once, so... I guess we could capture some... Yeah, okay, so let's change this function. So I guess I want to make this one return the delta time as well as the total elapsed time. Like that. That's gonna be that, and we need some new... Yeah, because this one gets assigned, right? That's like the timestamp at the previous frame. So I guess we'll just have another one that's called start. So let's capture that one, and then we can just assign, make those the same. Sounds reasonable. And then yeah, and now we right. Okay, we have so this should be the exact same, I guess, except that we are subdividing by the start timestamp. That should give us the number of nanoseconds. This actually seems like, when does this actually run out? Like, if we're counting nanoseconds, how many seconds can we fit into a 64-bit uint? Well, let's not worry about that at the moment, I guess. So we'll have the total nanoseconds here. Elapse. Hello. I can't type. Total nanoseconds. That should work, and that's always going to be the start of the program. Seems fine, and this isn't even unsigned. I guess these are. Jesus. Okay, it's assigned long. Okay. For some reason. I feel like that should work fine. So we have the delta time. The delta time. Why am I typing it like that? PH. Elapsed time. Oh Jesus! What's happening? Okay. And these are doubles. I guess it's I think it's fine to have them as doubles, and then just, I guess, cast them when we need them as floats. Probably. Seems reasonable. So that's the number of milliseconds since we started the program, or started the game. Yep. Okay, so I guess, yeah, we set that in the render context. Might not be the best place for this actually, but we will have access to it anyway in the scene now. Alright, and since that's in milliseconds, we're gonna have to slow down that animation quite a bit. I was assuming seconds, so let's try that. Okay, that's a bit much. Oh, alright, the weight. I should make this between 0 and 1, right? Okay, that looks extremely unrealistic because they're all synced up. So we should offset the sampling of this wind function. Let's actually call that wind. So we want some wind amount based on some t, and for now that's gonna be just yeah. Let's just do that. So we'll sample the wind at this time plus the X position let's try that. I'm not sure how much we actually want to offset it to make it look nice. We got some errors. How did that happen? Oops. But it's animation. What the fuck? Looks like an ocean wave. So we can make it a bit more complicated, and we might want to add some scale to this. Looks really unnatural, but what if we like oversample it? I think we need a way better. Let's scale that down a little bit, and we need some I wonder if I could keep multiplying this, is that just gonna look fine? At some point. It looks pretty cool, but you still see some regularities, right? Well, if we slow that down a bit, a lot of magic values going on. Maybe that looks cool. And I guess I could randomize the actual weight also. I think randomizing that could add some more. Well, obviously it's gonna make it look more random, but maybe more natural as well. It's not gonna make it like, it's not gonna be realistic at all, but it might look nice. So yeah, let us take some random value. Let's take how many bits should we take? Maybe 4. Let's call it weight, maybe. So well, let's see. Okay, so if we only do that, if we right. Oh, I don't know this. 7 is. Yeah, 7 is like the 3 bits to the left, right? Yeah, that's 7. So let's say that we have 1F bits. Well, actually, 1, 2, 3, 4. 5 bits. And we want to shift those. That's gonna be 20, 24. Doesn't look that much better. Maybe even looks worse, actually. Okay, let's skip that for now. Now I would like to add some different kinds of plants. Let's try to add a flower or something. So grow grass. We'll move all of this into some function that only grows a grass straw. Okay, and I guess for each plant we want to spawn, we'll take some random value, and let's say that for now we have 2 choices. So the first choice will be to grow grass at this position, and this could be a switch statement, I guess, but choice number 2 is to let's grow a flower And some easy way to make a flower. It's just 2 rectangles, right? Let's make 2 rectangles. So, yeah. Five, so 1 quad. 0, 1, 2. 0, 1, 2, 2, 1, 3. Is the first quad, and that one will have 4 vertices, and the width, yes, we'll have the width, and that should be like, let's do it like that, and that's, I think, correct. Let's make and those should be green, and let's think, the top. Yeah, 0 and 1 are the top vertices. That does not look right. I forgot to change the proper vertex. Makes sense. Okay, so we now have these flower stems that aren't pointy, and let's just put some okay, how to do this? I guess that's the stem, and this is this is getting really boilerplatey. We'll keep this outside, and this is the stem. And this, I guess it's called the flower head, right? Flower head. And that's also just gonna be a square. Square. That's gonna be centered around around the top of this, and we know the height. Okay, so that's gonna be our center. So how's that going to look? This will add height, and like I guess we'll have some variable for the size of the head. Make that some value. 0.2 is really big actually. Okay, 0.1, sure. And we should okay, so all of this should be the head size, right? And we should do the exact same. Well, wait. Okay, not the exact same. But we want to offset it by the size of the head. Like so. Let's make that yellow. Maybe. No, let's make red flowers. And these should all be animated. using the weight. And we just added 4 vertices. Okay, looks somewhat correct. They're like they look squished, like and we should make this taller. And let's remove a bit of like randomness on the height. But why are they not as oh, okay, that's a stem, right? Stem cell. But why is it oh, 0.5. That looks terrible, actually. And is the order wrong here, or? It doesn't look like these. The stem. All right. The stem. Okay, so these are the. I colored them a bit incorrectly. I got some fake shading. That still looks weird. Wait, the stem. 0 and 1 are the top. Okay, it should be like this. That red color is a bit too much. I feel like I should make this a bit darker. I actually want to add some more randomness, add back some randomness to the height. It looks really unbad when it's just completely unshaded. I can add some gradient, or maybe it's just because it's so damn bright. I made it completely bright red. Okay, let's try to make the top brighter. Maybe some fake lighting will improve the looks. Maybe I can add some different colors for them. how to do that. I guess I can have the... Could make it really simple. I guess just for the three channels, pick some random numbers. So we have the red, let's call them RGB. So that is our color, let's say, and that will be the color. So RGB. Maybe that's a bit too random, actually. And what happened with the... Oh, alright, it... 1, 2, 3, 4... Okay, sure, let's say that for now. And we want to make it a bit less bright. Dark color. And let's just divide all of these by 2. To make it a bit darker. And the bottom ones should have the dark color. Okay, there's some fake shading. I don't like that they're squishing together. So I could have a... I could have a some vertex information for just the face offset. I guess instead of using the X position. Or I could use the X position of the root. But then I... Maybe it's fine for now, I guess. It does look a bit too random though. Like nature doesn't look like this, right? I guess we could try to make this like a rose shape, like a cone, kinda. So the bottom ones, the offset should be a bit smaller. And that looks like some roses, right? Hmm. I would really like to have a player walking around here, so that could like push the grass around, or push around the flowers, to have some interactivity. Because I think this wind looks... it probably looks fine for now, actually. It probably looks fine for now. So, but how to do a... like, that's a fluid simulation, I guess. And the fluid we want to simulate is the air. Is it fluid and gas? It's the same thing physically. But let's see if there's some extremely simple fluid simulations, fluid simulation we could use. And I know you do it in a grid. Okay, this is cool. Okay. Take each grid point, move forward the direction and distance that would be traveled by a particle. At the grid point's velocity. Okay, okay. Right. Hmm. I guess I could try. Maybe we can add some player that walks around or something. We can do that with debug rendering right now. Okay, so first, I guess, right now the camera is centered around the player, but let's just create a separate camera object, and I guess the camera will have some kind of focus point, which makes sense. So the camera will have some position, and that will be the center that the camera is looking at. And what more? I guess the camera could also contain this. We got this right now. This view height that specifies the I guess this size of the area in the world in world space that we want to be able to see. At least the height, and then the width depends on the aspect ratio, right? So we specify the height that of the area that we want to see, and if we have a super widescreen monitor, then yeah, you'll see a lot horizontally. Okay, so we have the height, the view height, and we can just call it height, I feel like. Right. So we will have a camera. Let's create it like this, and the height. So the focus position, it will start at position 0, 0, right? And here, instead of the player, when we're calculating the camera, we should only need to pass the camera and still the aspect ratio. Yes, makes sense. Instead of just focusing it on the player always. So we'll use the camera. Oh, maybe I should call this differently. Let's call this scene camera, I guess. Or maybe the render camera. Okay, so we use the camera position and the camera height to do this, and we'll store it in the render camera. And use the game camera for that calculation. So right now, if I yeah, right now if I move the player, which I guess we can debug draw the player. We can debug draw the player. I guess let's do that in the rendering code. So player has a position, and I guess we can debug draw debug We can draw a cross at the feet. I guess the player is gonna have some kind of bounding box, but we can define that later. Okay, so the size of the cross and the color. Let's make it red. And this is a 3D point, right? I guess. Okay, so the player is moving around. That's the feet of the player. Makes sense. And I guess the player should have some bounding box. Let's put that just here in the player struct, I guess. So we will have some width of the player and some height of the player. Those could be constants, maybe, actually. Maybe. And let's initialize the player here. So we'll set some width and some height. Let's make the player 1 meter tall. Draw debug box. And maybe I should make 2D versions of these debug drawing functions, because this is gonna get a bit annoying, maybe. But let's see. So the first point of the box is going to be the position minus the width divided by 2. Yeah, in both x and y. Oh, this is gonna be really... and oh, right. Well, not the x actually, because I think the place could have some origin, and I think it makes sense to have the origin be at the feet, probably. Or maybe it doesn't matter even, but it feels like that makes sense. So let's make that yellow. And the max position, add the height. Okay, so that's some kind of a player. Now I would really like to create some kind of geometry editing. Some kind of editor, because this is completely hard code, and I want to make something a bit more interesting. if I wanted to do collision testing. But I guess I don't necessarily... I might not necessarily need that. But what I think I want to do... I need some kind of collision testing, right? So let's say that... I think it makes sense to... I think it makes sense to represent the whole world as triangles as well, in that regard. Because I have some idea of how I want the world to look. I don't want it to all be like rectangles and stuff. I want to be able to make like what's it called? Just completely arbitrary surfaces. Completely arbitrary convex surfaces, right? So I guess so if you ignore the level editing part right now, I guess just because we already output triangles in some sense. However, we only output them for the rendering right now. But I guess, and yeah, we don't want to output. Maybe we should separate this a bit, because we only want the ground. I wonder how to... it's gonna be a bit annoying before we actually get some kind of level editing in. But I guess we can just duplicate this code. So let's say that we have some... yeah, best way to represent this. Do we actually need an index buffer for these? Probably not. Probably not. So yeah, so okay, so the easiest, very easiest, let's go with the simplest. So we'll have some list of triangles that we want to collide against in the world, and let's call that let's just make a maximum upper bound for that. World max triangle colliders, let's say. Okay, maybe we should create we could make it like a collider world. World colliders, let's call it that. And we'll just put that here. So the world has some colliders in it. And for now, that's gonna be a bunch of triangles. We're not gonna use an index buffer. We could, but I don't think like the data is not going to be an issue here, really. Let's align all of these. All right, so we have some number of triangles, and let's also say that we have we keep track of how many we actually have. So we have the triangle count, We have some number of triangles. Okay, makes sense in our world that we want to collide against. Makes sense. So I guess when we... This doesn't feel like the right place to actually fill these, but... I guess we don't have to either. We can just... We can do this at startup. But it's a bit ugly to have them in completely different places. Eventually they're gonna be sourced from the same data somehow. But let's just do this at when we create this. So let's just say that we have make it ugly right now. So let's take the colliders. Have a shorthand, and we have the triangles. And for now, let's say maybe we can make this a primitive actually. I forgot, like, there's obviously 3 vertices in every triangle. So let's say that we have some kind of triangle collider. And that has 3 vertices, A, B, and C. Seems reasonable. Oh, and I guess actually it's not 3D vectors, it's 2D vectors. Right. I think this is correct. The triangle count is 2 triangles. And let's see, so we made the top triangle now, and let's start at this one, and we also need this one, yeah, right, that was already there, and we need this one. I think that's correct, and let's add some function for drawing, debug drawing. For debug drawing a triangle collider. Okay. And that's just going to be 3 lines, right? Do I not have the... I don't have the debug renderer included. Debug renderer. draw the... Oh, debug triangle. But, alright, okay, oh, so I actually... Okay. I guess in that case, let's draw a debug triangle. So the debug vertex... X... Y... Let's make that white for now. The A, B, and C vertices. Wait, is that actually a solid? Oh god, oh, that's a solid triangle. I want a wireframe. Okay, so I actually do have to. I do actually have to. Okay, I need to draw 3 lines, I guess. Let's create these vertices. I think that's it, and then draw the debug line instead. And let's draw these 3 lines. 2, 0. Okay, looks fine. Let's try this. We can do that when we update the world. Yeah, makes sense. Okay, there's nothing. Do I have depth testing on? That might explain this. Might explain it. So this is on X, Y, and Z and color. Okay. Why do I not see them? I see these other lines which are also at 0, like depth, 0 depth. And I do set the triangle count to 2, and these look fine to me. I could check render doc, I guess. That's it, right? The path. Let's see what the render doc says. Okay, so that is the debug renderer draw call. 48 vertices. And yeah, they are being drawn, but I guess I guess the depth testing. Yeah, okay, the depth test takes care of them, but why? But aren't my other debug drawing stuff also at like depth 0? So I don't see how these are different really. Is the depth different? No, the depth is 0 everywhere. But why are these visible and not? I guess let's look at the vertices maybe. Okay, so the position is not 0 of these in the Z. But why? Oh shit! Oh shit! Okay, I have to do that. I was oh, right. All right. Is it still running? No. Okay, cool. We have the collider triangles here. So let's add some collision detection code, I guess, or some intersection code. Right. I guess we can add some more colliders actually. We can do add some slope. Just something, we're not gonna render it, but we can add the collision shape for it. So let's say that we have the same vertices as these, except for this one. Let's move that there, and we can move that up a bit to make some kind of slope. Okay, that should be good for testing. Okay, and now the actual math behind doing some collision detection between a rectangle and a triangle, I'm obviously just going to Google that, because I'm not a mathematician. Triangle intersection. I wonder what I actually want also from the result of the intersection. I guess you want some kind of normal. And I guess you want to know how far you should push out the actual rectangle or the player, probably. Is there really a in the Mozilla web documentation? Okay, thanks a lot. I mean, okay, figuring out, do they have triangle? No. I mean, figuring out if there's an intersection, I think that's pretty trivial, I guess. But I need to know how to resolve it also. So I don't only need to know whether they overlap, but I need to know how they overlap in some way. I guess I could. I mean, there are some 2D physics engines, right? That I can just take inspiration from. Maybe Box 2D, I think, is open source. Oh, Box 2D Lite sounds even better, actually. I mean, maybe I can just use this also. Maybe I can just use a fucking library instead of writing it myself. Maybe. Oh, hello. What's an arbiter? Arbiter. All right. So we should probably look at the world first to get some understanding. So you add bodies to the world. I should actually I should just clone this myself. Okay. The world. So, okay, so we can add bodies. Then we have some kind of body list of bodies. Okay, that's all. And what is actually a body? I guess is it? Do they have different types of bodies? Is it just rectangles, or they have a width, a vector 2 width. It looks like a rectangle, right? Maybe I can build this also. Do I have CMake though? Yes, I do. Oh wow, it worked. First try. Now where is, I guess it's in samples probably. Samples. Samples? Okay, samples. Okay, cool. Alright, so it's only rectangles. Right. That's fun. Well, then we have joints. That's cool. A bit unstable. I want to grab it. And it's not deterministic, but that doesn't matter, I think. Not for me. Maybe this is could be worth to read this code maybe. Okay, so I guess an arbiter is some kind of and the contact is some. Okay, makes sense. Some information about the actual intersection. And then every body has a list of arbiters. So yeah, every body can have multiple arbiters acting on it. Okay. Okay, so it actually does all of the collision stuff in the constructor. That's interesting. Okay. Right. Okay, this is basically what I was looking for. Okay, this seems really... I mean, it seems complicated. I don't know. I mean, I could just literally use the Realbox 2D as well, maybe, but... I don't know if I want to use third-party libraries, though. But I've never done physics. Oh, and Box 2D it's C++. Oh, I forgot that. But they probably have a C interface, I guess. Yo, yo. Oh, I'm your favorite. I'm flattered. I wonder if they have C bindings for Box 2D. I assume not. So I would have to create some kind of wrapper if I want to use this. But physics seems difficult, and I'm not good at math. But I'm thinking about creating a platformer, so I'm obviously gonna need physics, right? Maybe it's not too difficult. Like, what do I actually need? I really like this demo. Okay, how difficult can it be? I mean, I guess the real Box 2D, if I look at that, I will get some... They will have some rectangle triangle intersection function that I can borrow or look at. What license is this, by the way? I guess it's like, yeah, it's MIT. That's good. Very good. Let's check this. Box 2D. I guess we can start in, there's some world, yes. So they have a polygon shape. I guess that's like probably a convex set of triangles. I'm gonna guess. Okay, polygon versus polygon contact. I mean, can't I just make everything a polygon to simplify things in my game, maybe? I can just make the player be two triangles, right? So in that case, I just need to figure out the collision between two triangles. But let's see, this polygon contact is colliding two polygons against each other then. Yes. The normal points from 1 to 2. Okay. Okay. the like force normal. What's a manifold? There's a maximum of 2. Okay. 2. Wait. Do not change this value, okay? Okay. Do not change. So is there like a, do they call it a box? Maybe a rectangle? I mean, surely there's like a rectangle shape, right? Or is that? No, there's not. Okay, is that a polygon then? Because I assume there's like something like a... let's check the demos, I guess. Or samples. Test bed. Sounds like it. Test. This is this actual tests and not like fun interactive tests? Let's see. We have a body definition. Okay, that's empty. Okay. An edge shape. So that's the floor, probably. Okay, column count. Yeah, that's okay. Makes sense. Makes sense. Okay, so the box is a polygon shape. I see. Interesting. And if I... What if you wanted to make some complex collision model out of triangles then? Is that also a polygon shape? Or is this like box and maybe circles? There was something to compute. I saw something to compute. The bounding box. Okay. Okay. So there is. Okay. So there's some number of vertices in the polygon. Okay. What if you wanted something more complicated then? I guess you can like weld, maybe weld things together, maybe. Or have some collection of shapes. So this then just... Okay, and the normals of the points of a box is, I would expect them to be pointing like outwards. Apparently not. Seems quite arbitrary. Are these public? Yes. Okay, that's unfortunate because the collision detection happens somewhere else. I think we were there before. Okay, then the normals are not used here. Yeah, this is what I'm looking for. Right, okay. The actual mathematics. So here I assume the normals are used somehow. Yeah, there's some transformation going on, right? You want using some shapes local space to do everything. It feels like if I just, all I care about is colliding a rectangle against a triangle, like, and for now I don't even want to rotate or transform this rectangle in any way. It feels like I could make some very simple version of this. So this whole intersection, it returns a manifold, right? Let's see what that contains. And I guess what do I actually need? Like, my rectangle is a player, right? I don't want... The only thing I want is to, like, I guess if I'm inside of a triangle, I want to push the player out in some way, or keep them from just walking through it, right? I don't want it to like bounce or make any like complicated physics, no complicated physics thingies. So it might actually be pretty simple. It might be... So every point... So there's some impulse. I think all I want, like, okay, let's say the player is standing on a triangle, I guess. And all I want, I guess, I just want to know in which direction to push the player out. Feels like, and by how much, how many meters, let's say. Is that simple? Maybe I can just try to do something, I guess. Do something really stupid, I guess. Could just brute force every point and brute force every... I guess we wanted to check the triangle edges somehow. Okay, let's try something. I guess start by trying... Let's test every corner of the rectangle against every edge of the triangles, I guess. And let's make it really, really, really stupid simple for now. So... Alright, for every triangle, this could be pretty simple, I think. Okay, so let's see, we will have the... Oh, world. Alright, I shouldn't do it here. I should do it... okay, I need some way of getting these... getting these triangles out, I guess. Okay. So we need some kind of world collision info, maybe. And I gotta... I will pull this out. Those should be read-only. And this one actually doesn't have to even return a bool. This feels a bit stupid, but I like to keep the structure anonymous. And I'd rather retrieve some internal state with one of these functions instead of just accessing it directly. And that should be done in the game. So in the game we have some... we have the player inside of the game that has a position and a size. I guess we could make this size vec2 also. I think that makes more sense, actually. Let's change that first. Size.x. Wait, that was also the width. And the height is size.y. Okay. So, in the game, I guess we... when we're updating, ticking the game, I called it, okay, interesting. We could just... we need the world somehow. I guess we could pass it when creating the game. I think that's fine. And we'll just hold on to this for later use. So in the game we have a pointer to the world. Sure. And for now, yeah, let's just add some code here. Okay, so well, let's first, I guess, actually send in the world like that. Okay, now the game knows about the world, and now wait, does this work? No, I actually have to forward. Well, I guess I'll just include it here, instead of forward declaring that. Okay, so now we can get the collision info of the world. World collision, maybe. We can call that. Get that from the world. And this is a bunch of triangles that we want to collide the player against. So let's go through every triangle. And let's actually, I think this is going to be like a nested loop, so let's have a nice iterator name, actually. So we have the triangle index. Triangle. Okay, and we want to test some collision. For now, let's go through every corner of the player's bounding box. And there's only 4 corners, right? Yeah. Make this size too. There are 4 corners. And what are those exactly? I guess we can. We can pull those out first. So that's gonna be the player position. I will just make a shorthand for the player. Plus X. So those are the bottom corners, and then wait. Like so, that's the feet, I guess. and this is like the head, so we'll take the player height and add that on top. And I guess I can try okay, I can try debug drawing these. Draw debug point. Let's see if we got that right. Oh. I need the vec2 type in the header. Segmentation fault. Classic. Real classic. The world is null. The world is null. Right, because I forgot to actually assign it when creating the game. Okay, good. Corners look fine. Those are my corners. Okay. I actually think okay, the actual winding order of the triangle is going to matter here. I think the first step is going to be to figure out we're gonna take each edge of the triangle and we have to figure out the normal of it, where it's pointing. That makes sense to me, so let's try that here in the game. So yeah, we have the triangle here. And let's yeah, this actually, this can be just outside. Those are the corners of the box, and for each triangle we have some edges. And how should I define an edge? I guess I can define an edge by 2 points. Yeah, sure. Is that like this? Is that gonna work? Or is it the other way around? Is it like this? So I want an... okay. Seems flipped to me, but sure. Okay, so each edge has 2 vectors, and those are going to be triangle A. Okay, so we have the edges AB, we have the edge BC, and we have the edge CA. Right. Those are the 3 edges. And I guess for nice debug drawing, so I guess we can go through each edge. And for each edge we want to compute some normal of that edge. The normal. Okay, so the edge has 2 vectors. It has A and B. And I think actually to figure out the normal, we need to find the perpendicular vector to these, to the line defined by these 2 points. And wait, I think that is extremely simple actually. In 3 dimensions, to do this, you have the cross product. But I think it's extremely easy in 2 dimensions. I think that the normal is just... what is it? Well, I think if we... Do I have a vec2 normalize? No. I'll have to make that. I have to normalize a 2D vector. Let's do the sim implementation. So it looks like I need some more helpers as well. I need vec2 length and scale. Right. Oh, and the dot product. I need a bunch. Dot product. Like so, and the scaling the vector by some scalar value. Oops, did I forget to change that? Yeah. Okay. Should be fine. Okay, so I want to normalize this. So there's some vector that's oh. Okay, one good thing about C++ is having operator overloading for this kind of stuff. But I can deal with this. So we're subtracting b by a, so we'll get the vector that's pointing towards b from a here. And actually figuring out the normal from this, I think is as simple as, I'm not exactly sure about this. I think we just swap the x and y. I think that's it. Literally, that's the normal. It's that easy. Okay. And let's draw that so we can figure out, just for debugging, let's take the center point of these two vertices, which is going to be, I need to add those together. I need a function to add two vectors. Let's steal this also. And just remove the last component. Okay. I will be right back. All right. So if we taking the midpoint is very easy. The midpoint of 2 points in 2D space and 3D space also, I guess, is that you just take the average of them in each axis. So we just taking the average of 2 points is very simple, right? I just add them together and multiply it by 1/2, because we have 2 elements and we want the average of them. Okay, so we have the center. I guess we can call this that's okay. So we have the center, and I guess we can now draw a debug line going from the center. This API is pretty annoying actually. It would be nice to just have it accept vec2s. Pink. All right, from the center to wherever the normal is pointing. I think that makes sense. Okay, it's not quite right. These are pointing the wrong, kind of wrong angle. So, is it like this? Do I have to subtract some? Okay, that looks fine. Well, except for that these are pointing inwards. I want the normals to point away from the surface, and I will scale this down a bit. It was a bit hard to see what's going on. Okay. These look fine, but the winding order is wrong here. So to fix that, that's this last triangle, and to fix that I think we can just flip these two. Yes. Okay, so for each edge of every triangle we have some normal that it's pointing towards. Seems good, I think. Now we can use this normal to define a plane, and then it should be trivial to check for intersections at each corner of the box. Okay, so we want some planes, and planes, oh well, in 2 dimensions it's gonna be a 3-dimensional vector. Well, not really, but it's nice to represent it as such. Because what we want is, we want the normal, and we want some value that represents how far from the world origin that the plane is located from. And using those 3 values, we have basically defined a plane. in a nice. It's nice to work with that representation also. So the x and y, well, that's just a normal, and then we need to find out the distance from the origin. Why is this an error? Is it just IntelliSense? Yes, it is. Okay. So the plane, yes. And how to find this this point? I think it's pretty simple. We take the dot product of the normal and one of these vertices. It doesn't matter because both of these vertices are the same distance from the plane, right? Intuitively, right? The plane is defined by this normal, and both of these points lie on the plane. So I will just choose one of them, A, and I think this is I am wondering. So is that correct? If a point is in front of the plane, that's a positive dot product. And then we want to move it there. Yeah, I think that makes sense. Let's try that. So we have a plane for each edge now. Okay. So now for each point, let's actually do this collision detection before, so that yeah, let's just try first to see if we can find any collision. Has collision. That's false, and let's go through every edge and now evaluate this plane. So we have the plane, and evaluating this is as simple as taking the dot product. I want another version of this for the x and y. Yeah. X and y. So we get the x and y components from the plane, which is the normal. So that's the normal, and we dot that with the. Okay, so we can pull out the corner here. Actually, we want to dot that with the corner, and now, and somewhere I think it's minus the plane distance from the origin. So this is sum. This is the distance to the plane, right? And if the distance to the plane is negative, that means we have a collision. Well, does it? Well, no. Okay, it doesn't mean that we have a collision, but we actually have to, I guess, we have to be behind every plane. Okay, yeah, every plane. So we need to, I guess, we can count the number of intersecting planes. Yeah, that makes sense. Right. So we have to be behind every single plane. And let's change the color of the point depending on the state here. Let's make it red if we are colliding, and otherwise we'll make it yellow. That's working. Maybe it's hard to see on the stream, I don't know now. But yeah, okay, so if the point is inside of the triangle now, it's red. Okay, it's not working here though. And why is... Oh, wait. Right, this loop happens for every single triangle. Right, so we're just overdrawing. What's a good way to fix that? Maybe we should look over the corners first, and then for each corner check the triangles. Or, well, there should not be any... Every corner should only have a single triangle intersection, right? But do we even care about that? Maybe instead, I think figuring out like the normal that we should move this point to. I think that should be simple to figure out. Okay, let's try to draw that, I guess. So I guess we need to keep track of the actual distance. I can already foresee many problems with what I'm doing right now. But let's just go with it. So we'll keep track of this. Edge index is this. We'll save that for later, and then we want to find. Well, I guess we don't actually have to do it. We only want the do we want the closest? No, we want the we want the closest, maybe. Closest distance. Well, okay, we want the maximum actually. Well, okay, wait. We only want the maximum when we have the intersection. Oh, I think we need some more information here, maybe, but okay. And we keep track of the closest edge. I don't think that's enough, but we'll see what happens. So that's going to be the edge index. Okay. And let's make this... is there a FLT FLT... Yeah, you can just take a negative FLT max, but where is that, actually? Where is that defined? FLT max. Float.h, likely. Yes, FLT max, we take a negative of that, so that this will be called at least once, and that's gonna ensure that. Maybe I want to initialize this just to be safe. So if we have a collision, we can check the closest edge, and we store the planes. We can look up the plane again. Plane. Right. And we get the normal from the plane. And we also store the max distance. So what if... well, I want to draw a debug line. From the corner again. And now I want to offset it by let's like that. Let's see what happens. Okay, that's it's pointing the wrong way, but yeah, there's gonna be a bunch of problems with this approach, but we did figure out where I guess we want the corner to be for the rectangle to have been pushed outside of the triangle. Well, not in this case, but Okay, this requires some more thinking, but I wonder what... maybe you want to check the center of mass, or maybe... Yeah, this is completely wrong, right? I wonder what I want to... Okay, it's something at least. I wonder if I... It would be fun to try, I guess, actually pushing out. Actually moving the box also. So I guess that would be... If we just... I guess we can do it just here in place. So this vector is the push, call it push out maybe. Okay, so we can just do it right here for now. So we have the player position. We just want to add this push out vector to that position, and in theory it should resolve the collision. Yeah. It does. So I can't walk into the oh except for this edge case. Except for that, like yeah, I'm just sliding now. I'm pressing up, and I'm not going into the triangle, which I guess that's pretty cool. But okay, in theory. Let's try to add some gravity to the player, maybe. So when should that be added? I guess we should add the gravity before we do all of this collision testing. How does that work? I guess... then we needed to store some velocity in the player. So the pair has some velocity now. And use some arbitrary gravity factor. And I guess after we push out, Let's see here. So if we have a collision, we want to modify the velocity somehow, right? Let's just try to set it to 0. That's not gonna look that good, I think. It's not moving down. Oh, right. I have to... the position, I just have to add the velocity. And I don't have a fixed time step right now, which is unfortunate. I can try just multiplying this by delta time, but I don't think that's correct. The player is gone. Okay, the player is sliding downwards by gravity. Looks terrible. Now what's happening here? Oh, well, I guess it's if I alt tab, the player disappears. Why is it so fast? No. Okay, let's start the player at some different position and we could make the player jump in a very crude way. If we are pressing space or holding space, we'll just set the velocity to some constant value. That's a bit much. Okay, nice. Nice. This is so janky. Oh. I have to. Okay, let's move the player a bit. Maybe to. Okay, so start on this ground. I mean, it's kind of working. I don't think the player should be sliding though, because of gravity. So we actually want to push out vector maybe it should depend on the steepness of this of the ground, but fucking goofy ass. Okay, why when I tab down, when I alt tab the game, it the player like falls through the ground. I guess it's something with the delta time. Probably. This looks so fucking goofy. Goofy ass platformer. Stuck in the ground. Shit. Okay, now what? I mean, I can improve this a lot, potentially. The collision, well, obviously, I like, if I walk incorrectly on the triangle, I get stuck in the ground, right? That's definitely a problem. And it's jittering. It's really jittery, but that's I wonder why. Well, I wonder. Maybe it's fine if I just okay, let's, instead of like pushing out, let's see, push out. Let's see. Let's first, I guess, let's wait until we've actually done the collision test against all corners before we start. Yeah, before we actually push out the player. So I guess we'll do that when each triangle has been checked, when all corners have been checked for a single triangle, then we can push out the player position. Right, and the amount. We just push it out by the maximum of all corners, and that also has obvious issues, but let's try that. Okay, so I guess before we go over, we need to find the push out. So the max distance is negative, so flip it and then... well, we could keep it negative, so this should be the smallest. Okay, then the max push out is the current push out of this corner. Okay, and then when we're done checking all corners, then we can do the push out. Only if this is not top max, because then we don't have a collision. Then we just do this that we did before in here. Max push out. Right, and that's already scaled. The player is still jumping up and down a little bit. Well, I guess that's... well, that is interesting. When do I actually draw the player? Yeah, I do it after the ticking is done, and like... oh, never mind, I think. Oh no. Yeah. I mean, it's working. Kinda. I have to fix the jumping though. How can I do that? Because right now I can just hold spacebar and I'm flying away into space. So I have to keep track of I guess we should know now if we are on the ground. So let's we can keep some state in the player for that. Is on ground or is grounded. Is grounded. So let's reset that every frame, and then if we actually have to do a push out, that means that we are grounded. Let's say that for now. That's not gonna work for walls, but okay. So now that when we check if we're pressing space, we also have to make sure that the player is grounded. So if we're pressing space and they are grounded, then we can jump. Maybe I should lower the gravity a bit. That's still a lot of gravity. Wow, it's almost a game. It's almost a game. It's actually pretty fun to jump around, I must say. Oh! There goes my hero. Yeah, it's almost a game. Happy. I guess I could make some I really want a level editor now, because adding triangles by hand is a bit tedious, I must say. So let's see which one is which here. So I definitely want the -1 and the minus this one, yes. And I want -1 and -5. Oops. Right, and those normals are flipped. More collisions. Guess I can try rendering this. I can try adding some rendering for these. God. Yeah, I really need a level editor. Okay, this is fine. Yeah, I just have to change these values now, which are going to be... Well, I know we had -5. -5, and these are probably gonna be 0. Yeah. And well, let's see how that looks. Like, looks like nothing. That's strange. I just changed 0505. What is going on here? Oh, right. I should have done this. So we need to take the index. Wait, no, the vertex. Wait. Yeah, the vertex count here. All right. Same thing here. Okay, good. And let's try to move that up on the left. So on the left I put it at 1, I believe. So 1.1. Right, on only the left one, obviously. I can try to make... let's make the camera follow the player. So where should I do that? I guess after collision detection and everything. That should be simple. So let's just take the camera position and set the focus position on the player. That feels... I could use some smoothing here. And I guess the very simple way is to lerp. Yeah, I can add a vector lerp function. Vec2 lerp between A and B by some factor of t. And what is that? Do I already have a lerp somewhere? Yes, it's like that. Yeah, and let's just do that for each component, right? For X and Y. So we want to lerp between the current camera position and the player position by some factor. Let's make it. Let's focus it actually on like the center of the player, center of mass, and we know the player size. So just let's add that divided by 2, or half of that. Alright. We have some rudimentary collision detection now. Very rudimentary. However, I feel like I really have to add a level editor. Yeah, I really do. I really do. And then if I have a level editor where I just block out these, I guess platforms, you call them, or collision geometry, then it should be simple to just scatter these flowers on like every single grass patch, and maybe we'll have like hanging vines as well, right? We can spawn decorative rocks maybe procedurally and all of that. Yeah, it would be cool to get some parallax background in also, I guess. Somehow. Not sure how I want to... how that would really work. Well, actually making some parallax stuff, it should be very easy, but... I wonder if we really have to use textures or not. Maybe we can use geometry in the background as well for parallax stuff. That should be possible. Yeah, but okay, I guess once we have a level editor, that should be easy. That is some progress, at least today. But that's it for now. I'm gonna take a break. I probably won't stream anymore today. Oh, I know. Wait, let's add, let's commit this. I guess we made flowers. We added flowers. Add flowers, grass and foliage animation, player collision detection, player movement. Platformer. That's it, and it would be actually fun to. I guess we can make a. We can just make a direct comparison, right, to what we started with today. So we can check out this. This one, this commit, and let's make everything and run. So this is what we started with today, and this is what we have now after 3 hours, more or less. I think that's a cool little difference, I guess. But yeah, whatever. I am done for today. Bye bye.